Today we'll discuss a interesting problem on capacitor. Okay, so here we consider a capacitor is connected with a cell with a source, and the switch is open. At first, suppose the uh, electromotive force of the cell is E, capacitance of the capacitor is C. As soon as you close the switch, the capacitor start getting charged, and after it gets fully charged, I again open the switch. Okay, that is, right now this capacitor is fully charged. This capacitor is fully charged. Now I open the switch. Okay, and in this situation, if I feel the region between the plates by some dielectric material having dielectric constant K, you have to find out what is the value of the charge, what is the value of the capacitance, what is the value of the potential difference between the plates, and what is the change in energy. Okay, so we'll have to calculate all these quantities. Okay, I again repeat the problem. Here a capacitor is charged with an source having electromotive force E. As you close the switch, the capacitor gets charged, and after that I open the switch. At that moment the capacitor is completely charged. Okay, now I fill the region between the plates of the capacitor with some dielectric material having dielectric constant K, and you are to determine what is the value of the charge, what is the capacitance, what is the potential difference, and what is the change in energy after filling the region between the plates of the capacitor with the dielectric medium having dielectric constant K. Okay, so let us try to solve. Here we first have to think that this capacitor right now, it is isolated one. Okay, that is, this capacitor is fully charged and it is isolated one. So definitely the charge have no path to move to another object, because this one is isolated one. Okay, there is nothing, nowhere to go the charge. Okay, so that the charge remains same. The charge remains same. Okay, what is the value of the capacitance? The value of the capacitance should be K times of C. The value of the capacitance should be K times of C. Now, what is the difference in potential? That is V prime. You know, Q is equal to CV. So here you should have to write capital Q. Q here, so you have to write Q prime by C prime. So Q prime is equal to Q and C prime is Kc. So you can write Q by C, it is V by K. So this is your answer. after disconnecting the capacitor, if you feel the region between the capacitor by any dielectric constant, dielectric, sorry, dielectric constant K, then as the system is isolated, at this capacitor system is isolated, the charge having no option to move. Okay, so the charge remains same. Capacitance, you know, when it is filled with some dielectric constant K, the capacitance has changed to K into C. It is K times of C. Clear? And finally, V prime equals to Q prime by C prime, and the potential between the plates decreased by the times 1 by K. Okay. Now we'll calculate the change in energy. How do you calculate it? Here, the change in energy can be easily calculated. Initially, the energy stored in the capacitor as you charge the capacitor with charge Q, it becomes Q square by 2C. Okay. Finally, the energy should be written as it is Q prime square 2C prime. And now we have calculated here Q is equal to Q prime. So it is Q square, and in place of C prime, you can write KC. Okay. So it is 1 by K times Q square by 2C. Okay, which is nothing but E1, which is nothing but 1 by K times of E1. So energy has decreased by 1 by K times of its the initial value. So from here you can easily calculate the change in energy. It is final energy stored minus initial energy. So final energy is 1 by K times of E1 minus E1. Here you can take common as E1. It becomes 1 by K minus 1. Okay. So this is your final answer. Now this is your homework. If the same situation is same, that is, you will try this at your home. Here is the capacitor you charge by the help of a source, electric source of electromotive force of suppose E. Okay, so that the potential difference develops V. Q charge is restored as you switch off, if you close the switch, and without disconnecting, remember, without disconnecting, you feel the space between the capacitor with the dielectric constant K. Okay, at this time the capacitor is not disconnected. Okay, so you are to find out the same quantities, that is value of the charge, value of the capacitance, value of the potential difference, and also the change in energy. Okay, this is your homework. Please try at your home. Thank you.